You have recalled in our previous discussion, we have discussed about three different kinds of schedulers, right? One is short-term scheduler or CPU scheduler. Second one is the long-term scheduler or job scheduler, and third one is the medium-term scheduler. Correct? And we have discussed what are the functions of these schedulers. The long-term scheduler will bring the program job into the ready queue, and what it does, it creates the process, right? It controls the degree of multi-programming, and very infrequently it is being used. It's not that frequent the job scheduler works. Whereas a short-term scheduler works very frequently. It select a process from the ready queue and give the control to the processor, so that processor could start its execution. So for that it uses a module called the dispatcher. We have another scheduler over here is called the mid-term scheduler, medium-term scheduler. What it does, whenever there is need to take out some process to the secondary device, and when required we will bring it back. In that case, the medium-term scheduler will come into. So these are the three different kinds of schedulers we have discussed. We'll see that what is the difference. What if you try to compare these three schedulers, long-term, short-term, and medium-term schedulers? What are the differences and common over here? For the long-term scheduler is a job scheduler, and short-term scheduler is a CPU scheduler. So job scheduler means we will actually here although we say job and processes are the same, but here the processes will be brought to the ready queue by the long-term scheduler itself. The processes, it is a process swapping scheduler. So if whenever we need to take out some process to the disk secondary device, then only the medium-term scheduler will come to act. So it selects processes from the pool and loads them into the memory for execution. Try to understand over here. Here it says that it selects processes from pool and loads them into the memory for execution. So it was before it was there in the pool, it selects and load them into memory. So from the pool it will bring to the memory. What a short-term scheduler, what it does? It selects those processes which are ready to execute. That means among the ready queue it will select a process. But here the swapping will occur, so it can reintroduce a process into memory and execution can be continued. So it will reintroduce, right? So in long-term scheduler, the speed is lesser than short-term scheduler. It's very infrequently it is being used. Where the fastest is the short-term scheduler. Short-term scheduler is the fastest. Long-term scheduler is less than short-term scheduler, where medium-term scheduler lies between these two. The speed is in between both short-term and long-term scheduler. It controls the degree of multi-programming. Who controls? The long-term scheduler controls the degree of multi-programming. The question might come that which of the scheduler controls the degree of multi-programming? Which of the scheduler is responsible for creation of a process? Which scheduler executes very frequently? Right? Which scheduler selects a process from the ready queue? So it provides lesser control over degree of multi-programming. And medium-term scheduler it also used for reducing the multi-programming by taking it into secondary storage device. So it is almost absent or minimal in if you come for a time sharing system, then this is almost absent. This is almost absent in time sharing because long-term scheduler is not required over here, because in time sharing we know that time slot is given and which process to brought to the ready. Here CPU short-term scheduler also very minimal use, and this is a part of time sharing system because it has taken to the secondary memory. So here we have the comparison among the three different kinds of schedulers. So we'll have another concept over here is called the context switching. Very interesting concept over here, context switching. Yeah, you know that there are multiple processes are there in the memory. processor could execute only one process at a time. The processor could execute only one process at a time, but multiple processes are there in the memory. So how the processor will switch between these processes? Suppose it is executing process 5, then it will go to process 7. So once it goes to process 7, there might be a chance that all those tasks that has been completed for process 5 may be lost. So, but it has to return back to the process 5 again, right? So how the switching of the control from one process to another process takes place, correct? So while it is taking place, the control transfer takes place between the processes, all the information related to the process, that is called the context, all the information related to the process need to be also switched, right? So this is called context switching. We'll go for that. What is each? Many times the operating system switches the CPU from one process to another. This is known as context switching. So many times what operating system does, it may need to switch between the processes. In case of context switching, the system must save the state of the old process and load the saved state of the new process via a context switch. See how this being occurred. It says that suppose it has to transfer from one process to another process. What it will do? It will save the state of the old process. So previously, whatever till now it is being executed, it will be saved, and it will go for the, and it will load what? It will load the saved state of the new process. Correct? So this is known as context switching. So what is this context mean? Context means the process represented in the PCB. The process represented in the PCB. As you know that all informations about a process is kept inside what? PCB, process control block. Process control block has all information, process ID, process state, link to the pointer to the child, pointer to the parent, how many registers, what registers are being used, all informations are there in the PCB. So that we say as the context. So while it is transferring from P5 to P6, for example, so the P5 process state has to be saved, then it will go to the P6 and load the state of the P6. So again, when it will come back to the P5, the P6 state has to be saved and the P5 state has to be reloaded. So context, now see, suppose more times the context switching occurs. There are many times the context switching occurs. Whether it will be good or bad for the system, we can say if more times the context switching occurs, more time, because I have 5, 10 or 20 programs, many programs are there, many processes are there in my memory. If the context switching occur many times, whether it is good or bad, anybody who can answer this one? Anyone who can answer whether the context switching is good for the operating system or is a bad for the operating system? Operating system point of view. Anyone? Are you there or not?
Yes, sir. It helps in multitasking, I think.
It will. Yes. Okay. I will. That is on answer. Anyone else? Okay. See, although the context switching, by using the context switching, we are going for multitasking or multi-programming. But while for every switch, every time the process switches, we have to do these two work, save and reload. Save and reload every time it will do. That will take extra time or not? Every time I have to switch from one process to another process, I have to save this one state, a PCB of the previous one has to be saved and the new one has to be loaded. So when this occurs very frequently, because I have many processes are running and it has to be done very frequently. So much time will be involved in this saving and reloading of the task. Yes, so it is it's bad a time. So therefore, the context switching is a pure overhead. The context switching is a pure overhead. Context switch time is pure overhead. The system does no useful work while switching. It is only saving and reloading, right? It is not executing any user command. So the more complex of the operating system and the PCB, the longer the context switching. Definitely, if the more complex the operating system and the PCB, if more informations are there in the PCB and the operating system programs, then definitely it will take longer time for context switching. The time dependent hardware support. Some hardware provides multiple set of registers for CPU. So multiple context loaded at a once. So some hardware provides, so what it does, sometimes a hardware support we have time dependent time dependent hardware support. What it says, it provides multiple sets of registers for CPU. We have multiple sets of registers. What it leads to? It leads to multiple context loaded at a particular time. And context means what? I said already. Context means the information about a process which is being stored in the PCB. So where it works over here, just see into this diagram. The process is admitted to the ready queue. It goes to the CPU. From CPU, two things may happen. A IO may occur. It will go to the IO queue, and IO event completed. It will go to the ready queue. But while executing in the CPU, the context switch may occur, or some other the priority may occur. In that case, it will be swapped out. It is just partially executed, swapped out, and again it will be added to the ready queue. Right? So this here only the context switching will occur. Here only the context switching will occur. Right? Just look into this diagram. This is a very interesting diagram over here. Assuming that I have two processes are running in the system, process P0 and process P1 is running in the system. Right? Now, suppose process P0 is executing, P1 makes a request. P1 makes a request after P0, P1 makes a request. So P0 is having an interrupt or system call over here, right? So now P1 wants to execute. Try to understand. P0 is executing, P1 wants to execute. So we have a system interrupt over here. So what it has to do, from P0 it has to go to P1. So which process state has to be saved? P0 process state has to be saved. So save state into PCB0. Which state to be reloaded? This state to be reloaded. So reload from state PCB1. So once it is reloaded, means which active now? PCB is what? This process P1 is active. P1 is executing now. You can see over here, P1 is executing. The P0 is idle over here. The P0 is idle. Now a IO occur and P0 now request. After P1 it has to come to P0. So which state has to be saved? From P1 it will go to P0. So P1 need to be saved and P0 need to be reloaded. So that is done over here. P1 is saved. The PCB1 is saved and PCB0 is reloaded. Now this is in execution stage. But now this goes to the idle. Correct? So every time a interrupt or a system call occurs, it saves the PCB, the content of the PCB or state of the PCB, and PCB of which process? Currently executing process, and reload the content or state of the PCB of the newly admitted process, newly requesting process. Is it understood? Now see here. The context switching is a mechanism to store and restore, the state or context of CPU in PCB. This will be stored in the PCB so that a process execution can be resumed from the same point at later time. Why it is being saved? Why it is being saved? Because it has to, suppose P0 is executing, then it goes to P1, and where it will come back again to P0, it should resume from the position from where it has left. All the variables that it has changed, or those has to be kept intact, so that while coming back, the control will return back to the previous process. So using this technique, a context switcher enables multiple processes to share a single CPU. So I will have multiple processes, but there is only a single CPU. So I will have multiple number of processes, correct? So here we can see the process P1, save the process P1 and restore the process P2. Here it saved, if another request will come, it will save the process P2 and restore the process P1. That diagram which I have explained in the previous slide. So it is an essential part of multitasking operating system feature, right? Why it is an essential part? Because in multitasking, more than one program is executing, and that is the reason we need the switching of the context, or we see the context switching must. But we know that this context switching is a pure overhead, extra time. If you are going for multitasking, if you have a context switching, then it's a pure overhead. When the scheduler switches the CPU from executing one process to another, the state from the current running process is stored into the process control block. After this, the state of the process to run next is loaded from its own PCB and used to set the PC register, etc. So this is we can see the summary of the context switch, what it does. So which information that usually being stored? We store the content of the program counter, the scheduling information, base and limit registers. We store what currently used registers. Now we store the change state and IO state information, accounting in all these informations which are there inside the PCB and need to be stored. Is the context switching understood to everyone, or anyone having doubt on the context switching? Is there any query for context switching? Okay. Operation on the process. What are the operations that we can do on a process? What is a process? I already said process is when the program is in the state of execution. It is in the memory. Process means it is in the memory, not in the secondary device. So what are the operations that you can do? Processes in a system execute concurrently. Processes in a system execute concurrently. More than one process can execute at the same time and will be there in the memory. So the processes should be created dynamically and deleted dynamically. There must be some mechanism to do that. So while there are multiple processes may enter and they may be deleted, how this can be done? So two things. One, dynamically we need to create the process, and dynamically we also want to delete the process. Dynamically means at the runtime we have to do both the tasks. So system must provide some mechanism for process creation and process termination. So we'll see that how a process is being created. It says the parent process can create child process. Parent process can create child processes. So I can use some system calls to create child processes. We can write programming, maybe in our lab class, maybe after 1 or 2 classes, we will be writing programs for creation of the process. We can create process of our own. So, but a process can create other processes. This means that there must be a parent process, a single process from which the other processes might have been created. The first process created when the system boots or the operating system is loaded, at that time the first process is created. INIT is the first process that is being created with process ID 1. From that it is being created. So parent process can create child processes, which in turn create other processes, forming a tree of processes. So processes that we are running may be a child of some other process, right? So there are multiple processes of the operating system. Operating system processes may create other processes, like that. It's a tree is being created. And what is the first process? The base process is INIT. Correct? So the process identified and managed by a process identifier. Every process has a unique ID. Every process has a unique ID, is called the process identifier or PID. Correct? Every process is uniquely identified, and that identifier is generally known as the PID. So resource sharing options, a parent and child share all resources, right? They can share all resources. Child share subset of parents resources. It might be a chance that child can also share only a part of the parent's resource, and there might be a chance parent and child share no resources. Parent and child share no resources. So there are three different ways it can be done. So one way is that they may share all resources, they may not share any resource, or a part of the resource of the parent can be shared by the child. A part of the resource may be shared by the child process. Is it clear? Resources means, which are resources? Resources are hard disks, memory, BOS, registers. These are resources. So if a parent process is running and you are creating a child process, usually it is a duplicate of the parent initially, but I can execute two different programs in two different processes. So initialization or input may be passed along by parent process to the child process. If I want to pass some argument, it has to be passed through the parent process initially. How they will execute, this is what they will do for the resources. I said for resources what they can do, they may share all resources, they may not share any resource, or it is a subset of the parents. About the execution, parent and child may execute concurrently. They may execute concurrently. While parent is executing some instruction, then child will execute, then again parent, it may execute concurrently, or the parent will wait until its children terminate. The parent process will wait till its child processes terminate. Is it clear? Or anybody having doubt for this parent process and child process? Anybody having any query for parent process? Parent process can one process. I told the first process is, which is the first process? INIT. INIT is the first process that is being created by the system. First process created by the operating system. First process is INIT with PID 1. Then we have, from that only the other processes are being created, and any program that you open, has a process having a process ID. Okay. So two things we have discussed. Two things. One is how they will share the resource. Second one is how the processes will execute. How they will execute? They both can execute concurrently, or parent has to wait till the child will complete. How they will share the address space? Child process is a duplicate of the parent process. Child process is a duplicate of the parent process. So initially it will just a duplicate of the same, it may be, or child has a program loaded into it. I may have, suppose that I will create a child, actually. So child is a duplicate of the parent initially, or I may want the child has to execute another process of its own, another program of its own. These things will be better understood when you will execute, when you implement on the lab, that how these processes are created and you can execute a program in the child process itself. How to execute, how to create a process? Fork system call creates a new process. To create a new process, the system call is fork. And to exec system call used after fork to replace the process memory with a new program. Fork system call is used for what? For creating a new process. If you want to execute another program in that new process, I will go for this execute or exec system call. These are system calls. The details about the fork we will read in the lab. For the time being, you remember fork system call is used for creating new process, and exec or execute system call is used for running a new program in that process. So see over here is a fork is being system call is being made. So parent is executing. So the fork parent will execute. It may go to the wait state and it may resume. And if fork system call, the child will create, in the child I may execute a new program by calling this exec system call. Child will finish its execution, then the parent has to wait till the time. Even if it has been completed, the parent is waiting over here. Is it understood? Parent is waiting over here because the child has not finished the execution. When child has finished the execution and exit system call, means the last instruction is being executed, then parent will resume its operation. So parent is just waiting over here with the doing anything. So this is one of the state where parent will wait till the child has completed his execution. This is this one. Parent waits until children terminate. Parent waits till children terminate. This is the diagram. Parent wait till the child terminates. So parent is waiting over here. After that, it will resume. Okay. So this is about the process creation. Now for process termination, process executes last statement and then asks the operating system to delete it using the exit system call. Process executes the last statement and wait till the exit system call is made. So when the exit system call will be made, suppose child has finished and it will execute the exit system call. So the child process may return data to its parent process through this wait system call. It may return, or the processor resources are deallocated by the operating system. When it is terminated, the resources that are being allocated to the newly processed or the child process will be deallocated. It's no longer required, so it will be deallocated by the operating system. But during the execution, suppose child is executing, parent is waiting over there, the parent may terminate the execution of child process. The parent may terminate the execution of child process by using the abort system call. There is a system called abort which will terminate the child process forcibly. A parent process may terminate the execution of a child process for a variety of reasons. Why do you terminate? Why the parent process will terminate the child process? These three things may happen for which the parent will terminate. Why it is? Child has exceeds its uses of some of the resources that's been allocated. Child has exceeds its uses of some of the resources. So suppose child process is allocated some of the resources, but it has exceeds the use of those. Then it has to be terminated. Task assigned to child is no longer required. I have assigned a task to the child to find some within a range. My value I have got. So child process is no longer required to be execute. I will kill the child process. Parent is exiting and the operating system doesn't allow a child to continue if its parent terminates. Now parent process needs to be terminated, but the child must terminate then the parent. So what the parent will do, it will kill its child. Is it understood what I am saying? The parent process, the child process should terminate and then the parent process. Sometimes parents want to terminate anyway. So what it will do, along with termination, it will also terminate its child or it will kill its child. In operating system commands, we said kill, it will kill those processes, child processes, right? So that means parent is requesting for killing of its child processes. Is that clear? So parent is exiting, so it is coming out. Operating system doesn't allow a child to continue if the parents terminate, right? There is a query that resource sharing example. Okay, what is the resource sharing is that says that suppose parent process, one of the process you are running a program where it requires the child process requires a part of the hard disk and a part of the memory. 100 MB of memory is allocated in which the child process should run, or it can allocate memory maximum of 100 MB. Now, due to some reason, child is allocating more than that, or child is process is allocated for one hard disk to access, it is requesting to two hard disks, it is accessing two hard disks, right? So it exceeds the uses of some of the resources. It has been allocated. That means it is an illegal operation it is doing, and that need to be terminated. So immediately the parent process will call the abort so that the child will terminate. Okay. See here. Here says some operating system do not allow child to exit if its parent has terminated. In some of the operating system, what it does, they do not allow child to exit if its parent has terminated. If the parent has terminated, it will not allow the child to exit. So therefore, what you have to do, if a process terminates, then all its children must also has to be terminated. I told now only, if a process terminates, if a parent process terminates, then all its children must also terminate. Many of the operating system doesn't allow. So it allows that if you are terminating, it will terminate along with all its children. Correct? That is called the cascaded termination. That is called cascaded termination. All children, grandchildren, etc. are terminated. So along with that, that process, the entire tree for that particular process, entire tree, the children, grandchildren, whatever, right? This termination is initiated by the operating system. This is really costly for the operating system. Sometimes, for example, sometimes there are four files you have opened in MS Word. 4 files you have opened in MS Word. I'll close MS Word. What will happen? So parent process is MS Word, inside which we have 4 files or 5 files you have opened. If the parent one you are closing, all those processes
Sir, your voice is breaking, sir.
Right?
Yes, sir, your voice is totally breaking. Not audible at all.
Okay, let me check it.
Sir, not audible.
Is it audible now? Hello?
Yes, sir.
Sir, still breaking.
Yes, sir. Audible. Okay. See, it says that a process, when a process is terminated, along with that process, all its child processes, grandchildren, everything will be terminated. So I am saying that this process of cascaded termination is actually maybe sometimes costly for the operating system. Why it is costly? Because some of the processes may be half in the execution, some of the data may not have been saved, some are being having some resources taking, you are forcibly terminating at the middle, right? For example, your Windows is, you are working in Windows and you do not, you have no UPS is being connected to you. When you start, what it gives, either down properly, so it will try to recover itself, right? So because there are many processes switch of the system, the processes are not been saved, correct? Because there are many processes might be there on the memory. The parent process may wait for termination of a child process by using wait system call. So the parent have to wait over here by using which system call, by wait system call. The call returns the information and the PID of the terminator. Whoever the processes, the child processes which are being terminated, those process ID, those PID will be returned over here. So this is the syntax that you use. Wait is the system call, ampersand of status, it will return over here to the, it will be stored over here in the PID. PID is any unsigned integer will take over. PID is not negative, it's an unsigned integer generally we take. You can take integer also. See over here, this is important. If no parent is waiting, if no parent is waiting, that means did not invoke the wait system call, so no parent is waiting, the process is called a zombie. The process is a zombie. A zombie process, also known as the defunct process, is a process that has completed execution but still has an entry in the process table. Why it is there in the process table? A process has completed its execution, but completed its execution means it must be terminated, but will not terminate. Why it is not terminated? Because maybe it's child processes are executing. Child processes are not returned the wait, has not invoked that wait system call, right? Because I told you parent process may wait termination for a child process by using wait system call. This is not being called. The process, the parent process doesn't know that what is going on, so it is has executed all its last statement, or it has executed completed its execution. But as the child processes are running, so there will be an entry in the process table. That number is still there in the process table, even if it is not doing anything. So it's like it's a zombie process, right? It's like we say we are thinking that it is alive, but it has already finished its execution. It has gone. It has all its work has been done. But process table is showing it is alive because the child processes are executing, right? On contrary, if the parents will terminate, if parent terminates without invoking the wait, the process is an orphan process. The process is an orphan process. A process which parent process has finished or terminated, though it remains running itself, those are called the orphan processes. So in the process table, when you give the ps minus el command, you will find some processes with Z symbol, that means those are zombie. If it is O, that means it is orphan. If it is EX or is executing, or S plus sleeping. So more about this zombie process or fun process, sleeping process or executing these 4 states will be discussed in the lab. But for the timing, you remember that zombie process where the process has completed its execution but still has an entry in the process table. Orphan process is if parent is terminated. If the parent is terminated without invoking the wait, then it is a orphan process. Is that clear? Any doubt?
Sir, once again the orphan process.
Okay. See, first thing that going for this orphan process or zombie process, do remember this line actually. This line says the parent process may wait for termination of a child process by using wait system call. Correct? When sometimes the parent process may wait for termination of a child process. By what? By using the wait system call. If no parent is waiting, then that process, that means the zombie process is a process that has completed the execution but still has an entry in the process table. It has completed the execution. If it has completed its execution, it must have been terminated. It must have been terminated, but it is not terminating because it has not got any wait system call. Because it has not invoked any wait system call. Okay, suppose the process is there. The parent has terminated without using the wait system call. Suppose the parent has to terminate, then it has to use the wait system call so that the child process will execute and it will terminate. If the parent terminates without invoking the wait, the process is orphan, right? So the process whose parent process has finished or terminated, though it remains running itself. It is running, but its parent has been terminated because of some reason. Either forcibly or due to some reason it has been terminated. Then this process becomes a orphan process.
So, sir, child process is running itself.
Child process is hello.
Itself. So, sir, the child process is.
We have executed a child process, but when do remember whoever is terminating, suppose parent is terminating, it should give a wait system call and it should terminate in that way. Here it says the child doesn't know that parent has terminated. The child doesn't know the parent has terminated. How the parent will terminate then? Because we know that when parent will terminate, along with the parent, child must terminate. But while terminating the parent, we have done it forcibly or due to some malfunction, the parent is terminated and it is not giving signal to the child that parent has terminated. In that case, child process is executing without the parent, which is not present now. In the process table, it is not present. Now, how to which it will be added? It will be added to its grandparent. It will be added to its adopted by its grandparent. In that case, it will be automatically be added to the grandparent. We will find that parent address will not be there in the table. The parent address will not be there in the table. Although it has been, although the child is running, the parent process ID which you have, which it has been assigned earlier, it will not be there. For example, if I say process ID 5 has the child 7, 5 has the child 7. Now, if I give the command PID PS -EL, I will find that for 7 the parent is 5. 5 parent may be 3 or something else. Now, if I kill 5, now 7 doesn't have 5 as the parent. The 5 has already deleted. So now it has become orphan. The moment it becomes orphan, it will be taken care by its grandparent. That is the process 3. Is it understood?
Yes, sir.
But not to worry that this is only some theoretical concept over here. The lab I will explain you in detail by running the code. We'll have codes for this. We'll write the program for this. Okay, we have two different kinds of processes. One is called, concurrent process execution in the operating system may be either independent or cooperating processes. When processes execute in a system, many processes are executing. These processes may be independent. When you say processes are independent, if they do not share any data, if they do not share any data or instructions, then they are called independent processes. If P1 intersection P2 intersection P3 intersection Pn is equal to 5, if P1 intersection P2 up to Pn equals to 5, then it is an independent process. If it is not 5, that means some information or data they are sharing, then we say it is a cooperating process. Is it understood? Two processes, they do not share anything, they do not share data. Processes which cannot affect or be affected by the execution of other processes. These processes do not share any data. So what do we say over here? Neither they affect other process nor they are being affected by other process. They cannot affect or be affected by the execution of other processes. They are running, they are running independently, independent processes. Right? Cooperating processes, the processes which can affect or be affected by the execution of the other processes, where there must be some relation between the process, there might be sharing some data, then we say cooperating processes. In a sports event, if 5 people are running in its own track, they are running in its own track, they are not they are not going to, they are not changing that track, they say independent. But in a relay race, they have some communication over there. One has to pass to the another one. So there might be some cooperation is required. It's a cooperating process. If each process is running independently without sharing anything, they are not affecting other processes or not being affected by the other processes, then we say it's an independent process. Now we'll say that why the process will cooperate? All should have independent process, all will execute independently. What is the need of cooperation? What is the need of cooperating the process? It says that processes need to cooperate for information sharing, computational speed up, modularity, convenience. But these are the 4 things for which the processes need to cooperate. Processes need to share some information. Sometimes many users may be interested in some piece of information. In those cases, we should allow the concurrent access to this type of resources, right? So many users may be interested in some piece of information. So they have different processes, but they want a common data to be shared. Computation speed up. I want this one work to be done by multiple processes. A subtask may be divided. I want to add 2 matrices, 100 cross 100 matrix. I will run 10 processes. Each one will be given 10 cross 10 matrix to compute. So every process will do the same task. I want to have a computational speed up. Modularity. We may construct the system in a modular fashion by dividing the system function into separate processes. My work will be divided into multiple number of modules, and that may run in different processes. In that case, they need to cooperate. For convenience, sometimes an individual user may have many tasks to work on one time, such as editing, printing, compiling. This has to be done, and for his convenience, he can have multiple processes. But they need to, whatever it is editing, he wants to print it. Whatever is editing, it needs to be compiled. So there might be some relation between them to pass the informations, and that requires the cooperation. So these are the things for which the processes need to cooperate. And many practically in our operating system, many or most of the processes are cooperating processes. If it is an independent process, then we don't have to do anything, because they are neither affecting nor being affected. But in practical, many processes are cooperating processes. When it is a cooperating process, we have to take care of many things. How they will pass the information, how the information among the processes can be passed, if it is being modified, how it can be maintained. So there are several things has to be done. So we'll be discussing those again. That how these what cooperation among the processes or information sharing of the processes can be done, right? Let me take the attendance first, otherwise respond to your roll number. No, sorry, roll number 2. I don't find over here. Roll number 2, 3, 4, 5, 6. Roll number 6. Six is there. Let me see. Pratik, your query I could not understand. Sir, what? And roll number 10.
Present, sir.
10 present.
Yes, sir. Present, present. Roll number. What I
20
have given.
to
Yes,
20,
10 given.
25, 27, 30, 37, 39, 49, 68, 73. So let me one. For module 2 process management, I think the PPT I have already sent. For this process management I have not sent. I want you let the module complete. I will send. Otherwise, what will happen? You will. I doubt whether you will read from these classes or not. So I want you to attend the class regularly. See from the PPT, and PPT is only to help you, right? So just by distributing the PPT is not solve our purpose. You read from the PPT is what I am discussing. I'll give it, there is no problem. But this is roll number 14 and 29. 14 and 29 is present. I have already met. 14 and 29 is present. So let me call once again the absent is roll number 2, 6, 22, 25, 27, 30, 37, 39, 49, 68 and 73. Okay.